So this is our final short paper for today. So thank you very much, Gideon. And this is Gideon's paper on free will and quantum mechanics in light of the metaphysics of John Duns Scotus. So I will hand over to you, and when you're ready, you can get started.
Now, my paper is entitled Free Will and Quantum Mechanics in Light of the Metaphysics of John Duns Scotus. All right. Part 1, Introduction. Although we do not often think about it, the world described by modern physics is quite different from the world of ordinary experience. We experience ourselves as conscious agents making free choices within a world of ordinary substances, of rocks, trees, tables, and many other things. These substances appear to lie on a flat and unmoving surface. The history of science has already, in a sense, been an undoing of these. In the ancient world, the Earth was proven to be round, and famously in the 16th century, evidence of its motion began to be put forward. The development of atomic theory put forward arguments that substances were nothing more than a collection of small particles, and quantum field theory has merely substituted fields for particles. Arthur Eddington famously summed this up in his thought experiment of the two tables. In front of me, the table appears to be solid, made of wood, etc. But science would say that it is actually just a collection of particles, which are themselves just fluctuations in quantum fields. Nonetheless, these differences are not of great importance for daily life of most people. As Eddington goes on to point out, it's not too important whether the table in front of me is thought of as a solid substance or a collection of atoms, which are mostly empty space. In either case, I can still expect my computer not to fall through this table during my talk. What is of much greater importance, though, to the average person is consciousness and free will. Can my thoughts and choices as an active agent really influence the world around me? A strong case against the power of free will to influence the world has recently been put forward by Carroll. Carroll argues that what he calls the core theory, i.e. the standard model of quantum field theory plus weak energy general relativity, can explain all everyday phenomena. Well, we know that quantum field theory runs into contradictions with general relativity at certain extreme cases, such as at the center of a black hole, and that there are likely new high-energy fields we are not aware of. None of this would affect anything that happens in daily human life. Every single part of our bodies and every single interaction we engage with can be reduced to this core theory. This core theory has been highly tested, and many parts of it have arguably been proven to a greater degree of accuracy than any other scientific theory. Is that there might be a deeper, more underlying theory than the core theory. That underlying theory must itself give rise to quantum field reality. Since the core theory does not include a consciousness field, Carroll reasons that consciousness must be an emergent property. If we zoomed in very closely, every fluctuation in every quantum field could ultimately be explained by the Schrödinger equation. Carroll therefore concludes that libertarian free will does not exist. Everything obeys the laws of physics, and there is no room in the laws of physics for free will. Carroll is a compatibilist, and so we can speak with the language of free will, but ultimately what he says he means by free will is that we have a lack of information. Since we do not know what a person will choose, we ought to act as though they have libertarian free will. Nonetheless, in principle, all their choices are reducible to the evolution of the wave function according to the Schrödinger equation. Can we save libertarian free will? Carroll argues that if there is a way to do so, there must be a mathematical equation that explains the influence of consciousness on the motion of quantum particles. Already here, an initial doubt ought to be raised. While in principle it is often thought that all systems are reducible to quantum mechanics, we have not been able to successfully reduce a science like chemistry to quantum mechanics. Thus, it seems to be an unreasonable demand that those who do not think consciousness is an emergent property provide equations. The mathematics of emergence is simply not there yet. Nonetheless, Carroll does raise a very important challenge. Ultimately, if conscious choices affect the world, this means they must interact with the laws of physics somehow. A central problem here is the foundations of quantum mechanics. Well, all physicists agree that if they use the equations of quantum mechanics, they will get the correct experimental results. There is no agreement on what those equations actually mean for the underlying reality. In order to reconcile quantum mechanics and free will, we will have to explore the foundations of quantum mechanics. In part 2 of this paper, I want to explore these foundational quantum mechanics. In part 2 of this paper, I want to explore these. In particular, I wish to draw attention to the many worlds interpretation, as this is Carroll's preferred interpretation, and it arguably reduces all of reality down to pure quantum mechanics more than any other theory. Since quantum mechanics initiated a significant revolution in how we understand physics, in part 3 of this paper, I wish to show how the shift from classical to quantum mechanics actually closely parallels an earlier revolution in philosophy in the late 13th and early 14th centuries, what I will here call the Scotist Revolution, on account of the pivotal role played by John Duns Scotus. In particular, we will draw attention to how Scotus had to transform Aristotelian philosophy in order to make room for libertarian free will. Finally, in part 4, I will outline a proposal on how we might use Scotus's metaphysics in order to answer this initial dilemma for libertarian free will proposed by Carroll. Ultimately, I will propose what I am calling the selected branches interpretation of quantum mechanics. Right. Part 2, the quantum revolution. Quantum mechanics completely revolutionized the way physicists understood reality. The classical paradigm, initiated by Galileo and Newton, is summed up well by Pierre-Simon Laplace. Laplace imagined someone, later termed Laplace's demon, who could know the positions and momenta of every single particle in the universe and could solve any mathematical equation. Using the laws of physics, Laplace's demon would be able to calculate the past and future positions and momenta of any particle at any time. Everything would be entirely determined by Newton's 3 laws with absolute certainty. This basic picture was shattered by experiments done in the early 20th century, which showed that at the most basic level, these particles act more like waves of probability than tiny billiard balls. Nonetheless, when observed, the wave would appear to collapse into a particle. 2 basic equations, known as the Schrödinger equation and the Born rule, govern the evolution of the wave and its measurement respectively. While the mathematics of this can be quite technical, we will here stick to the general philosophical concepts which come about as a result. One of the implications of quantum mechanics is that a particle can be in what's called a superposition. In a superposition, a particle is simultaneously in multiple states with a different probability of detection assigned to each state. For example, an electron before measurement could be in a superposition of being 50% spin up and 50% spin down. When measured, however, it will appear to collapse to only spin up or spin down. To be clear, it is not the case that it was secretly one or the other, and that it was only detected to be one way or the other. It can be demonstrated experimentally that it is really in a superposition of both before the detection. It is almost as if the act of measurement causes a change in the state of the particle. Since this happens on a very microscopic level, all these probabilistic changes tend to cancel each other out and lead to very little macroscopic effects. This is why Laplace's determinism seemed reasonable. However, macroscopic effects can occur. One such effect was suggested by Erwin Schrödinger in his famous Schrödinger's cat thought experiment. Consider a cat locked inside a closed box. Inside the box, this is a detector. The detector will make a measurement on a quantum particle. In this version, let's consider an electron which can be detected to either be spin up or spin down. If detected spin up, it will smash a bottle, releasing a toxic chemical which kills the cat. Before the measurement is made, the particle is in a superposition of being spin up, a 50% spin up and 50% spin down. And since the Born rule involves squaring the wave function, we signify this by writing a probability of 1/2 by writing 1 over the square root of 2. So that's just the math there, but you don't have to worry about that too much. However, the detector is also made up of quantum fields at the most fundamental level. Thus, when it makes a measurement, it too it becomes entangled with the particle. The detector itself enters a superposition. It becomes 50% detecting spin up and 50% detecting spin down. This means the poison is in a superposition of being 50% released and 50% not released. Most shockingly, This means the cat must be in a superposition of being 50% dead and 50% alive. Nonetheless, when I open the box, I will discover the cat to either be dead or alive. Opening the box almost seems to cause the cat to suddenly be determined as either dead or alive. And I actually used an app, you can get it, it's called Universe Splitter, to make a quantum measurement on this. So this was an actual test I ran. I didn't kill any cats involved, but I did test a quantum particle to do this. While some were initially satisfied to accept the act of observation does indeed determine the cat to be dead or alive, other interpretations of quantum mechanics have been proposed to explain this. One interpretation was proposed by Hugh Everett. Everett took Schrodinger's reason one step further. If everything is reducible to quantum mechanics, then I too am reducible. Thus, when I open the box, I become entangled with the contents of the box. I too enter a superposition of 50% seeing the cat alive and 50% seeing the cat dead. This result seems absurd. I have never felt myself in a superposition. However, Everett suggested that this is because I have mislocated my conscious experience. I am not really the whole superposition anymore. I am now one half of the superposition. There is another person, equally believing himself to be me, who sees the other result. This later came to be known as the many worlds interpretation. Whenever a quantum interaction occurs, the superposition of the particles entangle, and the world branches into multiple new worlds, each corresponding with a particular way the superposition could have been resolved if measured. To be clear, the many worlds interpretation does not propose that every possible world exists. Indeed, most possible worlds do not exist according to it. However, every possible evolution of the wave function according to the Schrödinger equation, given the initial conditions of the universe, do actually occur according to it. And since I used an actual quantum measurement to prepare this talk, according to Everett, there is actually another universe where all of you right now are watching this, but on the last slide, the cat actually survived. Right. In a sense, the many worlds interpretation can be thought of as a return to the world of Laplace's demon. Given the entirety of the wave equation of the universe, using the Schrödinger equation, the demon would be able to know everything that has happened and will happen. However, the demon will discover a nearly infinite number of branches or worlds which exist as a part of this universe. The many worlds interpretation therefore proposes that quantum mechanics does not require giving up classical deterministic paradigm, so much as transforming it to factor in these extra branches. Some have criticized the many worlds interpretation on the ground it introduces worlds that cannot be experimentally observed. However, David Wallace has fairly objected that the worlds are already implied by our mathematical equations. We cannot observe a planet 50 billion light years away, but we can know about the sand on its beaches just by assuming the laws of physics remain constant there. It would actually introduce more complexity to change the laws of physics than just to assume what the sand on the beaches is like. Likewise, Wallace argued, introduce more complexity to assume the wave function collapses, something never observed, than to assume the other branches exist in just the way the wave function says they do. Well, I think there is much more truth to the many worlds than its critics give credit for. It has to be qualified in light of another important revolution, this time in metaphysics. Part 3, the Scotus Revolution. Classical Greek metaphysics, exemplified by Plato and Aristotle, thought of the world as determined by natural necessity. Things had natures and acted according to those natures. Even the humans acted according to their natures. While their physics was quite different from the later physics of Newton and Laplace and lacked any mathematical formalism, the central principle of Laplace's demon that the past and future are as determined as the present seems to apply just as much in their metaphysical framework as in the later framework of classical mechanics. However, there does seem to be a bit more wiggle room to get out of the problem of determinism in Aristotle than Laplace. This is due to Aristotle's distinction between actuality and potentiality. For example, an acorn has the potency to become a tree, and once it becomes a tree, it will then be an act. This distinction is central to all of Aristotle's metaphysics and physics. Things are constantly moving between act and potency. One application of this distinction, which will be important for the next section, is that for Aristotle, all things are composed of matter and form. Matter is the principle of potentiality, which can be made into anything, and form actualizes matter to be a certain thing. In the example of a tree, the substantial form, which is its soul since it's alive, actualizes the matter to not just be a lump of material, but to be a living tree. This is known as hylomorphism. Aristotle's distinction between act and potency was revived in the early 12th century upon the rediscovery of his works in the medieval West. However, free will had to be reconciled with Aristotle. In light of Christianity, humans had to be free agents in order to make sense of divine reward and punishment in the next life for our actions here. Aristotle's distinction between act and potency seemed to allow for an easy place for this. There is a certain degree of potentiality regarding what might happen in the future depending on our free actions. Nonetheless, since we cannot retroactively change what might have happened in the past, this entailed a diachronic contingency, or contingency through the course of time. Once an action has occurred, it has a sort of retroactive necessity applied to it because it moves from potential to actual. If free will is linked to potentiality, though, this poses a significant problem for two Christian dogmas, that God has free will and that God is pure actuality. If God lacks all actuality, which is necessary for God to be absolutely perfect, then it seems that he cannot act freely. In response to these growing issues, which occurred through the reintroduction of Aristotle, in 1277, Bishop Etienne Tempier condemned a wide variety of propositions that limited God's free will. Tempier did not solve the philosophical problems, though. He only closed the door on the answers the church considered to be heretical. This left a challenge to the next generation of theologians. This provides the important context for the philosophy of John Duns Scotus. Born in 1265, Scotus was educated under the shadow of these condemnations. Although in many ways fond of Aristotle, Scotus realized important changes would have to be made to his thought to allow for it to be reconciled with Christianity. Scotus would do this through three key insights. The first of these was to change diachronic contingency into synchronic contingency, i.e. contingency at the same time. In synchronic contingency, the past possibilities remain possibilities, even if they will not and will never be actualized. If I chose to eat a sandwich yesterday, under diachronic contingency, the proposition, it is possible I ate soup for lunch yesterday, is now false. However, under synchronic contingency, the proposition remains true. At the same time I chose to eat the sandwich, the possibility of eating the soup was a real possibility. Hence, although it would be false to say I actually ate soup for lunch yesterday, all that is being asserted in the first proposition is that there was a possibility. There is no retroactive necessity in synchronic contingency. The potency always remains, even if its fulfillment is eternally frustrated. This entails Scotus's second key insight. There are really two very different sorts of potentiality at work. Under hylomorphism, which Scotus keeps, there is a subjective potency. Matter is a subject which has the potential to be actualized with form. Likewise, the acorn is a subject which has the potential to become a tree. However, Scotus also introduces objective potency, which is the potential for something to exist in the first place. There is an objective potency that I will eat soup, and an objective potency I will eat the sandwich, and the latter is actualized by my choice of food. Likewise, there is an objective potency with regard to the many possible worlds God could have created. Subjective and objective potencies are often intertwined. There is an objective potency with regard to the acorn will ever be a tree, and there is a subjective potency for the sandwich to be eaten. Nonetheless, it is important to distinguish these two aspects of potency. This leads to Scotus's final key insight here, the distinction between indeterminate potency and indeterminate actuality. While potency implies an indeterminacy on the side of the thing, in the classical Aristotelian view, actuality was something opposed to indeterminacy. However, Scotus argues there can be an indeterminacy of actuality. In this case, the indeterminacy is not located in the actuality itself, but rather in some relation to a potency. For example, since my soul, and hence my free will, is an act, it can have an indeterminacy with respect to the objective potencies of eating a sandwich and eating soup, even if, or even not eating at all. This is not some lack in my soul, but is rather grounded in its actuality. One important feature of this distinction is that, since the intrinsic indeterminacy is on the side of the potentiality, an indeterminate potency can be in contradictory states at once, whereas an indeterminate actuality cannot. This is what is most important for Scotus himself, since it means that God could be pure actuality, yet have the freedom to create many possible worlds. While these many possible worlds are any world which God could create, a much wider range of possibilities than simply what the wave equation allows. The shift in both physics and metaphysics from determinism to possible worlds invites a comparison between the two. All right, part 4, towards a Scotist interpretation of quantum mechanics. In this last section, I want to respond to the initial dilemma introduced by Carroll by reinterpreting the many worlds interpretation of quantum mechanics in light of Scotus. Like Scotus himself did, it will be most helpful if we start with an Aristotelian theory and then Scotize it. Werner Heisenberg, one of the foundational figures of quantum mechanics, argued that quantum mechanics is in a sense a rejection of the atomist theory of early modern physics, i.e. the view that everything is made of tiny indivisible particles. Instead, a particle is just shorthand for a wave of potentiality. He pointed out that this is quite similar to Aristotle's theory that matter is only a potentia. This claim by Heisenberg has led many Aristotelians to search for a fully fledged interpretation of quantum mechanics. The most successful of these, in my opinion, is the traveling forms interpretation by Robert Kuhns and Alexander Pruss. The key to this interpretation is not merely a revival of Aristotelian potency, but also of Aristotelian act, the substantial form. Kuhns argues that substantial form is necessary to explain what he calls thermal substances. There are many properties of a thing which are not reducible to their component parts. For example, temperature only makes sense in light of a much larger collection of molecules. Likewise, the powers of molecules are not reducible to their component parts. It is precisely this appearance of powers which is not reducible to their parts, which is a sign of form. Kuhns calls this irreducibility ontological escalation. At higher levels, we move further from the potency of matter to the actuality of form, and hence new powers appear. Nonetheless, the powers at the lower levels remain. When a substance acts upon matter, a new form is adduced from the potency of that matter, and the two come together as a singular substance. The restoration of form allows Pruss to offer a modified version of Everettian quantum mechanics. He suggests that the substantial forms of things travel along the wave function, which exists only as a potency. Substantial form moves to one branch, and so it is only this branch or world which actually exists. Let us now consider Pruss's cat. The electron is just a wave of potency, so it can exist in a state of both up and down without any problem. However, the measuring device is made of various substantial forms. Hence, the wave function must collapse when the measuring device makes its measurement. Hence, the bottle necessarily breaks, and the cat necessarily dies, as both of these were determined by the prior movement of the measurement device onto the spin-up branch. All that changes when the box is opened is the knowledge of the scientist. Right. Heisenberg, Kuhns, and Pruss provide an important step towards a Scotist theory of quantum mechanics. Heisenberg is correct that matter operates like a potency according to quantum mechanics. However, with Scotus, we must distinguish what kind of potency. Kuhns provides the basis for subjective potency. Form actualizes the potency of matter. However, Scotus allows for a plurality of substantial forms within a substance at different ontological levels, something Kuhn's denies following Aristotle. Scotus himself only applies his pluralism to living beings, but in light of modern science, I think we can suggest that inanimate substances may have a plurality of forms as well. I wish to tentatively suggest that the first substantial form exists on the molecular level, with quantum particles virtually existing within these molecules, as it is about this level that we see the shift from quantum to classical properties. The indeterminacy of potency allows for superposition, since the quantum wave function can allow for a particle to be in contradictory states at once, what we call a superposition. Nonetheless, I put forward this part of the paper only very tentatively, as I hope I can take up this question in a future paper. Following Scotus, though, we must also take into account objective potency. This is where Proust's contribution is very helpful. The various worlds or branches in the many worlds interpretation are objective potencies, and hence are synchronically contingent. Even after a measurement is made, the reality of both measurements remains. Potential being is not non-being. Potential being is real being, but it is not actual being. Hence, on this interpretation then, the many worlds of the many worlds interpretation all really exist, but they do not all actually exist. They exist in a similar sort of way to how the many possible worlds exist in the mind of God. The initial conditions of the wave function at the beginning of the universe determine all possible future configurations in this matter, but they do not determine which of these configurations actually comes to exist. Nonetheless, even now, all those possible worlds which did not actually come to exist still exist potentially in the wave function. Quantum mechanics, as a science, simply studies matter insofar as it is represented in the wave function. Nothing in the math can tell you about which world actually obtains. It simply studies potencies. Thus, the many worlds interpretation jumps from the potentiality of the many worlds, something the math does in fact state, to the actuality of many possible worlds, something unjustified. Let's return then to Schrödinger's cat. In the Scotist interpretation, there are two realities going on at the same time. At each stage in the wave function, Everett describes what is true in the sense of an objective potency, while Proust describes what is true in the sense of an objective actuality. The measurement device measures spin up, but potentially measures a superposition of both spin up and spin down. The bottle potentially breaks, but potentially remains unbroken. Thus, the cat actually dies, even if it potentially remains both dead and alive. Finally, when I see the cat dead, although I still see potentially both, since my conscious experience is something actual, I only actually see the cat dead. Nonetheless, these both remain real descriptions of the world. Now we must return to the original problem outlined by Carroll. Under the Scotus theory, is free will salvageable? It is here where the indeterminacy of actuality comes in. The human will is an indeterminacy of actuality according to Scotus. As we saw in Proust's traveling forms, it is form which determines which of the worlds actually comes to exist. It is my contention that, while most forms simply move along the wave function according to natural probability, the human will is perhaps able to choose which branch to move along. I call this the selected branches interpretation of quantum mechanics. While I do not experience this choice of quantum fields in my brain, this can easily be explained by Scotus's plurality of forms. There we go. It is the form of the brain which does this, and my soul merely directs my brain to this task. Well, an electron can exist simultaneously as both spin up and spin down, since it is an indeterminacy of potency. The human will is actual, and so the indeterminacy is on the side of the wave function. If I was thinking of eating a sandwich or soup yesterday, then, even after the eating of the sandwich, the possibility of eating the soup remains in a very real way under this selected. The previous description of Scotus's cat, though, I think remains the same, since the thought experiment proposed by Schrödinger does not depend on any choices by the scientists. How do we know, though, that the eating of the soup was even a possibility on the quantum wave function? In a case like Schrödinger's cat, humans are intentionally messing with the quantum probabilities in order to create very different results. Do such different, significant differences occur in the ordinary world? Future research ought to be done on this to see how different the branches are from each other on the many worlds interpretation. Roger Penrose and Stuart Hameroff have suggested, for example, that microtubules in the brain could allow for quantum effects to occur in the brain. While the theory of consciousness of Penrose and Hameroff is quite different from my own, I think this has opened the door to important future investigations which could have implications for both theories. Finally, Carroll's contention is that there should be an actually experimental way, at least in theory, such an interaction be detected. I think the selected branches interpretation does that. If the selected branches interpretation is true, then the ordinary probabilities of quantum indeterminacy no longer apply in at least parts of the human brain. This seems in a theory at least testable. However, in practice, it is likely impossible to do, as quantum detections require a highly isolated laboratory to avoid decoherence. Hopefully, future technology might be able to solve this problem. But for now, this will have to be left as a strictly philosophical argument. In conclusion, then, it seems that a return to Scotist metaphysics could help physicists and philosophers to interpret quantum mechanics. While I am by no means here claiming that Duns Scotus predicted quantum mechanics, it does seem that quantum mechanics fits neatly into the various divisions of being which were proposed by him. A Scotist metaphysics can account for both the unique actuality of the world we actually experience and the underlying quantum math, which demonstrates a real potentiality of many worlds. Most importantly, it opens the door to preserving a real freedom in our actions. There are no other actual worlds in which we might act otherwise, but we do in fact have the potential to act otherwise. Thus, we ought to seek virtue and goodness in this life, as there are us's to do it for us. All right, thank you. I think we now have some time for some questions.
We do. Thank you so much, Gideon. We will give you a virtual round of applause, which I know is never quite so satisfying as one in a room, but thank you very much. Really appreciate your paper. Does anyone have any immediate questions? If not, I've got one that I will pose, but I shall pose mine then whilst people cogitate. I was just wondering if you could expand a bit. You talked about the opportunity for sort of genuine free will, but I was wondering if you could talk about how your theory relates to omniscience, in the sense of how do we know about what is God's knowledge when we're talking about this sort of this real but not real, or this like, I wondered if you kind of expand on that, if you've had chance to think about that in your work at all.
Yeah, I think this is actually probably hit at the most difficult part of Scotus's theory to work out. And I'm not actually entirely sure if Scotus himself comes to a satisfactory resolution. Because in the earlier scholastic account, you can say that God knows our actions by being the cause of our actions. But that's going to create a real difficulty with the freedom in our actions. There was actually some later attempts to deal with this by Scotus. I think the most satisfactory account was proposed by Bartholomew Mastery in the 17th century. He has this whole theory that God can essentially virtually simulate our actions in his will. So he's able to cause all the worlds where we freely choose to act in a certain way. So he knows our freedom in a sense where he exists as both cause, but not necessarily a determinative cause. He actually wrote about 200 pages in Latin on this subject, and I've read a little bit of it, but I'd actually like to dive much more deeply into it. I can read Latin, but I'm not as fluent in it as I am in English, so it's going to take me a long time to get through all that Latin.
Thank you, Gideon. Really appreciate that. And yeah, 200 pages in Latin sounds like definitely some work to do in the future. Roger, you've got a question.
Well, thank you. Very interesting talk. I could feel my brain expanding while you were talking. I have a comment and a question. You haven't convinced me about many worlds theory, but I think what you say applies to collapse of wave function quantum mechanics just as well, really. I don't think it's safe to look for free will in quantum mechanics. Laplacian, the brain is a well-regulated clock with no freedom. In quantum mechanics, the brain is an erratic clock with random things. There's no intent in there. So that's possibly dangerous. The question is then, is the alive cat and the dead cat the same two states as your sandwich or soup that you might have eaten yesterday?
Yeah, thank you.
Alive and dead, you might have eaten both sandwich and soup.
Yeah, thank you for that. Yeah, so I think that to the first point, I very much agree, actually, that I think a lot of current attempts to deal with free will and quantum mechanics really don't work, because what they do is they build from the ground up. But as you're pointing out, if we're just building things from the ground up, if we seek it actually in quantum mechanics itself, we're going to end up in a very serious issue, because quantum mechanics simply works by a probability. I think what I'm trying to do here is showing that you can actually build it from the top down without violating the laws of physics by reintroducing substantial form. And that's actually, I hope to write a second paper on a Scotus approach to substantial form and hylomorphism within modern physics. I think this is also an important issue. I think Rob Koons has dealt with this well in another sense. Mariusz Tabachek has proposed another solution to this. So I think you can actually have substantial form within modern physics. And then once we have substantial form, then we have a room for the human soul, and then the human soul to act freely. But I think you're 100% right there of the problems of if you build from the ground up. Yeah, and then your question about the similarity. So I would say I'm pretty sure that it's the same similarity, right, of the cat being both dead and alive. It's both are true in a potential sense, but only one of them is true in an actual sense. And likewise, whether I eat the sandwich or eat the soup, both of them are potentially true, but only one ends up being actually true. I think the one sort of hang up I had as I was working on this paper is I said, I would like a lot better research from Everettians of how different do the different worlds in the wave function look like. And I think this is probably almost impossible to do simply because quantum decoherence happens to such an extreme degree that it would probably be almost incalculable how different these worlds are. So I'm not sure we'll ever actually get a satisfying answer from mathematicians of how different these worlds look like. But I would like to see some further work from Everettians, maybe making some possible predictions on this matter.
Roger, does that answer your question?
Yes, thank you.
Okay, then Andrew, you've got a hand up.
Yes, fascinating paper again. That was indeed very mind taxing. I don't know if my mind's expanded because I'm not sure I've got the capacity to take that in. But I do have a question about form, because if I understand correctly, you're relying on the existence of form, which is somehow able to make sure that the wave function collapses, and therefore, in what we experience as actuality, it's only one possible thing. How does form come about in your metaphysics then?
Yeah, so I actually have a lengthy footnote on this, and as I mentioned, I'd like to write another paper on this because I think it's an important issue. So I drew here quite a bit on Robert Koons' account of substantial form. But I actually think there's a slight issue in his account of substantial form, because he sort of sees it as at the Big Bang, there's sort of one substantial form that virtually contains within itself all the later substantial forms that will come to be. This is quite different, actually, from Aristotle's account of how substantial form comes to be, which is followed by Scotus as well in the Lectura. In this account, and I'm just following Scotus here as he elaborates it in the Lectura, he sees other substantial as potentially contained within matter. So you could consider all the configurations of what sort of forms matter could be in. And you'd say all of these are potentially contained within matter. But when form acts upon matter, and it has to be matter that's properly disposed by an earlier form, a new substance will act upon it, and what we call its adduction. So in actuality, brings forth the potentiality of the matter to bring forth a new substantial form. And I think this is actually similar to what's going on a bit in sort of the science of thermodynamics and this whole issue that's come about in the science of emergence. There's sort of this new growing field of, all right, we think in principle, right? All the properties of something like temperature are reducible to the motions of their particles. But very clearly, if you just take a particle on its own at that same speed, you're not going to get that property of temperature. You need a large collection of particles, and this property of temperature emerges. And so sort of a debate here of strong versus weak emergence. So Sean Carroll argues for what he calls weak emergence. That, yeah, it's simply because we're zoomed out so much that it would be really difficult to do the math and stuff to explain all these emergent properties, that we might as well speak as though these emergent properties are real. But I would fall more into the camp of what's called strong emergence, that it's still the case that it emerges from the lower levels, but something genuinely new comes to be. And in Aristotle's account, what's the sign sort of a new higher level of substantial form is that a new form comes to be. Scotus will actually deal with this quite a bit because now he has multiple substantial forms. And so he wants to argue, if you have multiple substantial forms in a thing, why isn't, say, the state a substantial form, or why isn't the whole world a substantial form? And so he'll distinguish the unity of order. So when you have a unity that comes about by the ordering of distinct substances, but not necessarily new properties arise, the properties are all, sort of a weak emergence happens, versus when he thinks a strong emergence happens, is the sign that there's a higher level of substantial form going on.
Fascinating. Go for that new paper and let us know when it's out.
Thank you, yeah.
Thanks, Andrew. Luke, you put a comment in the chat. I don't know if do you want to expand on it or speak to Gideon directly?
No, it was just a short comment to say that, of course, the Schrödinger view has prevailed in quantum mechanics, but there are some scientists that still endorse kind of less probabilistic view, like the de Broglie. I've heard a talk of a Dominican who argued that in this way it can be much more integrated within Thomistic Aristotelian philosophy. But yeah, so I was just trying to say that perhaps there are also non-probabilistic understanding of the quantum mechanics, and that will make things look very different. But it's a big question, so I don't know if you want to ask.
Yeah, no, I think that's an interesting point there, because I think fundamentally sort of the only two serious games in town for interpreting quantum mechanics is either some sort of Bohmian view with hidden variables, as you were articulating, or some sort of Everett or a modified version of Everett, like I'm proposing. I think the Copenhagen interpretation, it really tries to stand in this middle ground that doesn't work at all. There are some people I know of who've tried to propose modified Bohmian views or de Broglie views. Did you mention a Dominican? Is that Father Mariusz Tabachek?
No, it's another. I can email you. It's another Dominican in Italy. Yeah.
Okay. Yeah, that's the only Dominican I'm familiar with on this. But I encountered a similar approach in Father Andrew Yunon's account. He's trying to take this Thomistic approach as well, where he tries to modify Bohm, where you have this potential that's then actualized at the act of measurement. Wolfgang Smith takes a similar approach, where he says the substantial form is somehow contained in the measurement device, which then causes the actuality of the thing. I think that's possible, but it seems to me is going on in Bohm. It's sort of a resurrection of atomism that he wants to save, that deep down, no, everything is deterministic. There are some real hidden variable. And so it sort of surprised me that I've seen a number of Aristotelians take this sort of approach, whatever Aristotelian school you'd like to. Because it seems to me that what Heisenberg's hinting at, even if Heisenberg doesn't fully work this out, that what's going on here is we actually have a resurrection of potentiality. And so this should be something that should be totally embraced by Aristotelians, that sort of, even though most of the science of the scientific revolution turned out to be true, the underlying philosophy of corpuscular theory actually turned out to be entirely false. And I find that very interesting. And it also raises an interesting point for what epistemic weight should we place on various new scientific discoveries. So if these new theories might turn out to be true, but how much should they weigh into our philosophy? Because even though it seems like is going on as a scientific debate between hylomorphism and corpuscular theory, really what's going on here in many ways is a political battle between liberalism and Aristotelian views of politics. And the stage of the scientific ground is whose metaphysical picture of the world is correct, which will then justify your account of politics. And so this then raises a question fundamentally of how much epistemic weight should we place on these new scientific discoveries when it comes to these much larger philosophical issues in terms of especially ethics and politics?
Thank you.
Thank you, Gideon. Does anyone have any final questions for Gideon? Okay, in which case we'll give you a concluding round of applause. So thank you very much, Gideon, and thank you for your time today.